Welcome students, here we are going to discuss a topic algebra of sets from the chapter sets. And under this topic algebra of sets, here we are going to discuss identity laws. Identity laws. So there are two laws. First is A union phi is equal to A, and second is A intersection universal set is equal to set A. These two laws are known as identity laws. Identity means in spite of the operation, the set A remains itself. Here also in spite of the operation of intersection, the set A remains itself A. Okay, that's why these laws are known as identity laws. And now let us see the proof, how we can prove these laws. So starting the proof with this first part, where A union phi is equal to set A. Here we can prove that the set in LHS is equal to set in RHS by showing that if if A is a subset of set B and B is a subset of set A, then this implies that set A is equal to set B. And I am writing and here. A is a subset of B and B is a subset of A, then these two sets A and B are equal. Similarly, here we will try to show that the set in LHS left hand side is equal to set in right hand side, and again set in right hand side is a subset of, clear? I am repeating it. You will show that your set in left hand side is a subset of right hand side, and set in right hand side is a subset of set in left hand side. Then with the help of this property of sets, A is a subset of B and B is a subset of A, shows that A is equal to B. Here we will be able to say that set in LHS is equal to set in RHS. And how we can show that A is a subset of B? If you take any arbitrary element, say X belonging to set A is also belonging to another set B, it means set A is a subset of set B. So let us start here with the help of this assumption that let any element X belonging to A union phi. Okay, and what does it show? By the definition of union of two sets, X is belonging to set A or X is belonging to set phi. Of course, X may belong to both the sets, but if X is not belonging to both the sets, in spite of that, X may belong to A or X may belong to phi. So this shows that X is belonging to set A or X is belonging to set phi. If X is belonging to any one of these two sets, X will come in the union of these two sets. Okay, but this is not acceptable. There is a contradictory. Why? Because phi is a null set. Phi is an empty set. It doesn't contain any element. So X, any element is belonging to null set. This is not correct. There is a contradiction because phi is an empty set, null set. So no element will be a member of, will be element of null set. So we are coming to conclusion here that X is belonging to set A only. X is belonging to set A. Therefore, you see, here we have started from X is belonging to A union phi, and we are coming to this stage, X is belonging to set A. It means this is a subset of set A. So therefore, A union phi is subset of set A, relation number 1. Again in the next step we will try to show that A will be subset of A union phi. Then we will be able to say with the help of this property that A union phi is equal to set A. Also, let X is belonging to set A. But it is not necessary to repeat this process. There is a very simple way to come to the conclusion. If union of two sets is equal to A, or simply you can understand that A will be always a subset of A union B. This always exists. A is a subset of always A union B. So with the help of this property, we need not write this one. Simply we can write that by definition of union of sets, we can write here that A is a subset of A union phi. Suppose this is relation number 2. Here union of two sets. So one set is always subset of any one of union of two sets here. Correct? So combining relation 1 and 2, here set in LHS is a subset in set in RHS. Here set in RHS is a subset of set in LHS. So by combining relation 1 and 2, we can come to the conclusion that A union phi is equal to set A. This has been proved here. Correct? Now let us see proof of the second part. Here we will show that A intersection universal set is equal to set A. Our process will be exactly similar. First of all, we will suppose that any element X is belonging to the set A intersection universal set. If any element X is belonging to intersection of two sets, it means that X belongs to both of these two sets. So this implies that X is belonging to set A and X is belonging to universal set. Naturally, all elements belong to universal set. Okay, and if you write only one part of the statement, nothing wrong. So here X belonging to A and X belonging to universal set, we can conclude here that X is belonging to set A. This implies here. You see, we have started here that element X belonging to the set in left hand side. We are coming here that X is belonging to the set in right hand side. So therefore, set in left hand side, A intersection universal set is a subset of set A. Relation number 1. Okay. Now again, let any element X is belonging to the set in right hand side, X belongs to A. Correct? Then here this implies that X is belonging to this set A, and if you consider universal set, then universal set consists of all the elements under that particular context, isn't it? So you can write that X belonging to A and X also belongs to universal set. As I told you, universal set contains all the elements in that particular context. And X is belonging to here both the sets, in set A as well as in universal set. What does it mean? It means that X belonging to intersection of these two sets. belonging to both sets, so definitely intersection means common. So therefore X belongs to set A intersection universal set. Now you see here we have started from X belonging to the set in right hand side, and we are coming to the same element X belonging to the set in left hand side. So this shows that here A is a subset of A intersections U, A subset, and A again A is a subset of A intersection universal set. So by combining these two relations 1 and 2, we are coming to this result. So therefore by combining these two relations 1 and 2, we are getting A intersection universal set is equal to set A. This is proved here. So this is a very simple logical proof. Just it has been based on a simple logic. So hope you have understood it. And in the next video, you will see some another law in this topic, algebra of sets. So students, please subscribe this channel. I hope you might have subscribed it, but if not, please do it immediately and enjoy learning mathematics. Thank you very much. Wish you all the best.